Okay, today we're going to learn about program development and flow of control, basically the use of control statements. All right, creating software involves more than just writing code. A lot of times when we're given a task and we go right to coding, we end up working harder and not smarter. You should develop good programming habits. Basically, these 4 steps are the same 4 steps that you should use in solving all your problems. Getting that hot date, or fixing a problem at home, or writing a code program. All right, so here are the 4 steps. Establish the requirements. When you work in industry, you get a job as computer science, and you have your company, you're the entrepreneur, and people come to you and they want a program written for them. This is going to be very difficult for them to articulate exactly what they require. You're going to have some important questions to ask them. What type of output? What kind of input? What do you want things to look like? You got to figure out, what does it do? What do they want? All right. Second step, creating your design. Right? Third step, implementing the code. That means writing the code. Now, you have to look at this from a perspective. By now, at this point in your life, you should be able to write code like on the back of your hand, all right? And then you test to see if it does what it's supposed to. Software requirements. Software requirements will define what the program must do. The requirements must be clear, otherwise you're just spinning your wheels and you're going to make a product that doesn't work or doesn't meet the customer's requirements. Know what the customer wants. Software design. This is the hardest step in these 4 steps because you have to put the most amount of work into the design. How many different classes are you going to do? How are they going to be talk to each other? What kind of control structure are you going to have? How many methods are you going to use? What kind of algorithm, steps-by-step process to solve this problem? How are you going to do this? This is the hardest step. Now, once you have an outline, this software design is not written in stone. This is a guide. When you're actually writing the code, which is implementation, you might think of another way of doing it, a better way of doing it, so your design can change. Your design can change. Implementation. Implementation is the easiest part. Now, I say it's the easiest part. I know at this point in your life, you don't think coding is easy. But once you've graduated from college and you're working for a big-time company or working for yourself, coding is the least of your problem. By then you know what you're doing. So coding is the easy part. It may be tedious, it may take a long time, but it's not hard once you have a good design. Testing it. Testing it is basically running it. Does it output what you need? Are there any errors? Are there any logical errors? Can you break it? And what I mean by breaking it, can you add input that will make it crash? I don't think people nowadays want to buy programs that crash. Beta testing. I'm sure you've heard of beta testing. A lot of companies will push out a unfinished product because us geeks out here in the world will just want to tear it apart and send feedback to the mother company saying, this is what's wrong with it, that's what's wrong with it. And then they take all that input, which was free, and fix their program. Flow of control. All right. Computer programming, specifically Java, is top-down. When the program runs, it goes to the first line, then to the second line, then to the third line. Flow of control, whether it's a method or an if statement or a loop of some sort, changes the flow. All right. So today we're going to work with control statements, if statements, and if-else statements. All right, so there's conditional statements and there's loops. Today we're going to work with conditional statements that are based on a Boolean expression, which means something that's true or false. All right, so here are all the Boolean operators for numbers. A double equal sign will compare two numbers to see if they're equal. If you do a double equal sign and compare strings, you're actually comparing to see if their ASCII values of all the characters are exactly equal. An exclamation point with an equal sign does not mean that you're all excited about your equal sign or you're yelling, equal! No, you're not doing that. Exclamation equal sign means is not equal to. Then you've got the old familiar ones, greater than equal to, less than equal to. The only thing different is the greater than equal to doesn't have a single line underneath that V-like symbol. You have to first do the greater than symbol and then do an equal sign. Same thing with less than or equal to. If you're comparing strings, you use equals. This is if you care about whether it's uppercase or lowercase. Equals will check to see if it is exactly the same. If you don't care about uppercase, lowercase, then I highly encourage you to use equals, ignore case. Especially nowadays that people text in all uppercase or text in all lowercase, you don't have to worry about the case of the word you're looking at. Conditional loops, later on we're going to learn more about while loop, do while, for loops. We're not going to deal with it right now. All right, so the if statement. Today we're working on the if statement. An if statement is basically how you ask a question in Java. If you want something to happen, you first have to get past this question. If the question is false, what you want to have happen won't happen. It'll skip over it. All right, so there's two types of if statements. There's a standalone if statement. All you have is if, Boolean expression, and then underneath it, an executable line of code like print or do math or something underneath it. Indenting this one line underneath the if statement is not required, but it's visually important so people can understand your code. And then after that one line, you have all the rest of the code going on. All right? So if this Boolean statement is false, it would skip over that executable line of code and continue on doing top down. All right, so we have a guessing game program. It's the bare bones one is sitting on Schoology. If you want to pause this and go upload it and get it open on JGraphs so you can fill in as I fill in. But first, let's do the design of the program. So I want to do a guessing game, all right? So first, the requirements. So I want to ask the user to guess a number between 1 and 100. All right, the user should respond with an integer because that's the particular data type that we need to use. And we want to guide them when we have the scanner ask them, please enter an integer between 1 and 100 and press enter. That would guide them. When you're writing a program, make sure that you guide them. So the program requirements is going to have guidance in it. All right, create a random number. We need to create a random number between 1 and 100, inclusive, right? And then we got to compare the guess. And if they're wrong, then we have to give some sort of response. And if they're right, we give some sort of response. All right, so it's kind of it's a guessing game. That's the requirements. Now let's go on to the structure. All right, so we got to come up with a name. I think we'll use guessing game. All right, import statements, we're going to use a scanner and we're going to use random. We need a scanner object, and we also need a random object. There, random number. Our variables is going to be a guess. That's what we're going to get from the user. And a target. That's what's going to be generated from our random number generator. We want control structures, ifs and if-elses. We're going to demonstrate those. We got a couple other methods. We might do initial values. All right, so initial values of 0. So we'll set everything at 0, so everything's cool. We got the main program that runs the program. We got the program itself that has all the executable code in it. And of course the two methods from the scanner class, nextInt and nextLine. All right. Oh, and I also forgot, random number dot random, right? We need that guy too to come up with our random, and we got to make sure we put the right number in here. In here we got to, int, num, some number goes in there, all right? Now to implement, we're going to write the code. So today we're going to write the code together. And then to test it, we run the program. Does it do what we want it to do? Is it formatted correctly? Not now, but later on, we're going to add protection to our programs so when we put in the different data types, it won't crash. But we can make our today's program is crashable. If we put a string in when they ask for a number, it's going to crash. So you just got to be, if you ask for an integer and you don't give an integer, then, oh well, you're an idiot. All right. So that's what we're doing today. Now go to video number 2.